Hi there, this is Jake and Mash, Precalculus lessons, and this is Unit 2, Lesson 6 on exponential input to output. So in these problems, you're given the input, which is t or x, whatever you want to call it, and you have to find the output. This one seems is going to be easier than what we'll do in the next lesson. Sorry that I don't have an intro because I just don't really feel like doing that right now. Okay. So, like I said, you're given the input, find the output. So, if there's this amount, what do you end with? This goes in, what comes out? So, how do you do this? You create the equation. Sometimes it's already given to you, but you might, and not in this case. So, create an equation and plug in for x. That's what we'll do. So, we have a problem here. So let me zoom this thing in. Okay, so as usual, I'm using a MacGyver, that's what's on the background. See, that's one of the videos that didn't work unless it got fixed, which right now, as of now, it's not fixed. On October 19th, 2021, it's not fixed. But anyways, I did have one video using a problem how he fell out of his Jeep. See, he crashed his Jeep and he came out of it. Okay. Anyways, that's the only thing I can think of to use as problem. And that's an 80s show, if you don't know what it is. Also, there's a new one now. So, whatever. And it also went into the 90s. That's why this problem's from the 90s. So, MacGyver, if you don't know the show, he goes places and he solves problems. Like he's often in a place where he's about to be exploded by something or something like that. And he figures out how to turn off a bomb or something like that. But he goes all over the world. And so let's just say he's at some island. The population of this island that he went to in 1994 was 8,283 when he visited it. The population, if it increases by 22% each year, what is the population now in 2021? Well, if it's not 2021 when you're watching this, then forget that. But still, we're going to use 2021 because that's not now. That might not be now for you, but it is for me. So first, let's write down the equation. Once again, I'm not using my usual stylus. Oh, hey, just found it. Never mind, ditch that thing. Okay, so the equation I told you about, now we know our exponential equation, it can be this, but that's not what one we're using in this case. We're using one that's the same thing, but yeah. So if it's if it's 1 plus r, I forgot to say that, then it's going to be growth, 1 minus r decay. So a of 0, that's what we're starting with. What are we starting with? We said the population was 8,283 in 1994. Now we need to figure out, is it growing or decay? It's growing because it said that it increases growing. By 22%. So 22%, that is the rate. So R. And we need to make that a decimal. So 0.22 is what the decimal is for that. If you didn't know how to do that, you just divide it by 100 or just move the decimal back. I think by now you would know how to do that in your head. I can, but you might not know, so whatever. And then now we have 1 and we make it a plus because it's increasing. T, we have T. Now, what we're being asked is what is the population in 2021? Well, what we need to do, so we are given the input. So we have 2 years, 1994, 2021, and T is our years because it says it increases each year. So T is years. So what we need to do, the population, whatever the population turns out to be, is our output, A of T. So we need to find A of T for a certain value of T. What value? Well, how many years are there between 2021 and 1994? We do 2021 minus 1994. That would be I could do that in my head, but I don't feel like doing that right now. So we do that, and 27 years. So we plug in 27 for t. Oh, I don't know what I just did. Sorry. It's a good thing this thing isn't delayed, because that wouldn't be very good. I'll just go ahead and change this to that, because that's what it would be anyways. And then we do 27. Now, I'm gonna need my I'll just use my phone just now for the other thing, but I'm gonna get my other calculator. Okay, I think the microphone is on my earbuds, so need to have them on, even though I'm not listening to it. Okay, so I have my graphing calculator. It doesn't really have to be graphing, but that's easier to me. So I do 8283 times 1.22, do the power button, 27, and what it says is a very high number. So this must be this is a realistic situation. Some places population have grown a lot. Now it doesn't say to round, but let's say we need to round to the nearest person, because that makes the most sense. So it is 1,777,883 people. And we need to say that. We need to say our units, which is people. So that's a very particular number, but no one can say for sure that it increases exactly by 22%. No one knows that. So here's a challenge. What was the population in March 2012? Well, we're given a month this time. What does that mean? Well, we do the same thing like when we did 2021, but we need to do 2012 this time. But it's going to be a little bit different since we were given a month. So 2012 minus 1994 is 18. But 18, now we know there's 12 months in a year. March is the third month. 3 divided by 12 is 0.25. So 18.25 is what we should do. That's what we'll plug in for t instead. So 8283, you might not have to do a problem like that. I just made that up. But now we're doing that. And make sure that's to the power of it. Oh, wait, hey, sorry. I was so used to looking at my tablet, I forgot to scroll down. Sorry about that. So that's 18.25 for the years. And that's what you do. So sorry about that. I'm so used to recording on my tablet. Forgot to scroll. And the answer would be 312,071 or 72 if you round people. So you can see that the population, this is why this is an exponential function. Look at how much it increased in just 9 years. It more than tripled. That's what those functions do. If you look at the graph, they start out going slow and then they go crazy. So now, what about this one? Let's pretend that instead of increasing by 22% each year, it does it by every 7 years. Then what would the answer to number 2 be? Well, our function changes a little bit. So we know our function that we came up with was this. It was this. But so if we know that would be the function if it increased by 22% every year. For every 7 years, that would mean for every year is a seventh of what it is for every 7 years. So we need to do t divided by 7 instead. Or really, we could do 1/7 t. Don't say 7t, because 7t would mean if it increased by 22% of a seventh of a year. It's opposite of what you might think. Remember, we learned about that in the transformations, because that would be our horizontal factor. So anyways, that's not the point of this, but that's just showing you that you would change that to 7. If it increased by a seventh of a year, then it would be 7t. If it increased every 2 years, it would be 1/2 t. Half of a year, 2t. So that's how it is. So instead, we use this equation, and it's saying, how would our answer to number 2 change? Well, we said that the years was 18.25. So this should be a less number because it increases less. So I'm typing it in, times 1/7, 18.25. Instead of 3,000 or 312,000, it's only 13,910 people. So that shows you if it only increases by 22% every 7 years, then that is a less number. So that is it for this video. That's actually the easier one. So hopefully you understand that. The next one's a little bit trickier. So that's it for this video. Thanks for watching, and I'll see you in the next one.